This is a very good representation of problems that will be on the test. Do you want to pay attention? Yeah, I would. I would. I would. Unless you want to.
No?
Nope. All right, Cameron. How do you want to start?
Okay. You subtract 2x from both sides.
Okay, you want me to work on this first equation?
Yeah.
And then we're going to subtract 2x from both sides. Everyone write this down, please.
I wrote it down.
Now what?
Divide the whole entire thing by -3.
Good. Okay, help me out. How am I writing this?
2 over 3x.
Okay.
Minus 2.
Good. Is this in slow form?
Yeah.
Good. Is this in slow form?
Yeah.
Yeah. Okay, so we can graph this out now, right? Okay, tell me where to start.
-2.
Cameron, -2?
Yeah.
Okay, then what do I do?
Up to right 3.
Okay, so right here?
Yeah.
So is that my line?
Yeah.
Okay? Okay, what about the next one?
You go to the origin.
Everyone pay attention, please.
Put a dot at the origin.
Very good. Why is it at the origin, Cameron?
Because there's no b, so you assume it's 0.
Very good. Okay, and what's my rise and run?
Up to right 3.
Okay? Okay, so what's going to happen here?
They're going to be parallel.
Mm-hmm. Whoa, hang on, that one's... How do we know they're parallel?
Because they have the same exact slope.
Very good. Now, watch this. Same slope, right? Same slope. Do they have different B's?
Yeah.
Yeah, one there, one there. Okay, so walk me through the rest of it. What's my...
Same slope, different y-intercept, parallel, inconsistent.
Cameron, what's my description?
Oh, wow.
Same slope, different y-intercept. Parallel, inconsistent, and it has no solution.
For classification. Now tell me, when they're parallel, can you tell me something about that?
You never
Oh, yeah, so they never touch, so you can't have.
Is that the only one that's ever inconsistent?
Yeah.
Yes, very good.
I said that yesterday, I think.
Yep, it's the only one, correct? Okay, and then what about the solutions?
0.
And why is it 0?
Because they never touch.
They never touch. Very good. Okay, very good. Any questions on that? The only thing that was really out of the ordinary was this right here. Just remember, when you don't have a B, use origin, okay? And what is origin?
The 0 point.
Very good. All right, Adrian, your moment to shine, sir. How do you want to start this one?
Let's start with the top one. and
Start with the top one? Okay. Tell me how you're going to do this.
minus x on both sides.
Very good. Okay, what now?
Then you divide it by 3.
Okay. Now what do I do here? How do I write this answer out?
1/2.
Very good.
And plus 2.
Good. Okay. If it's in a fraction form, you can leave it. Now I have a question. If this is an improper fraction, can we leave it alone?
Yeah.
Why can we leave that alone but not the B?
Because your rise and run.
Very good. So if you have 4 over 3 and it's improper fraction, you're not going to make it 1 and 1/3. That's going to be, you're not going to be able to graph that out. So you can leave improper. But what about the B?
B, you have to put it in there.
You don't have a choice because you can't graph an improper fraction. Very good. Okay, so we're done with this one? Okay, what about the next one?
Distributed property.
Okay, so tell me what to do. Let me write it out first.
Times -2 with y and 2.
So -2y, and then what's my next one?
-1.
Very good. Okay, how do I solve this now?
Plus 4 on both sides.
Very good. I'm running out of room. I'll bring it up here. Okay, what now?
Divided by -2.
Okay. So what's my final answer?
One.
-1/2 and -2.
Okay, are these the same?
Yes.
Are they the same?
No.
They have different y's, right?
Yes.
Okay, let's go graph them out and see what happens. Okay, Adrian, tell me where to start. You want to do this one first?
Then you start on 2,
2?
all the,
Okay.
then you go, I can see it. Oh yeah, up 1 over 2.
Okay, up 1 over 2. So this is my line right here. So down 1 over 2. Not exactly the scale. Okay, what about the next one?
-2.
Okay, -2. And then what?
Down 1 over, left 2.
Down 1, left 2.
Yeah.
Right? So what's going to happen with this line?
That's eventually gonna be a parallel.
Okay, let's talk about this. Even though this is -1/2 and this is +1/2, you're still going the same direction, right?
Yeah.
Because if you're going down 1 and over 2 versus up 1 and over 2, it's still doing the same exact thing on the line. Okay? So if we were to classify these, how are we classifying it? How are we describing it?
Same slope and different y-intercept, parallel, inconsistent, non-solution.
Yep, very good. That's it. So the only thing that was different in these two, okay? Don't let that negative throw you off, okay? At the end of the day, it's still doing the same thing because you got to go to the other side of the line because these lines are going on forever. They're not stopping, okay? Cameron, on this one, he remembered that you're starting from origin when you don't have a B. So that's the only two out of the ordinary thing on these two. Okay, something I want to point out in regards to the test, okay? Remember, parallel means none. They're never running into each other, right? If they intersect at some point, and by the way, if they have different slopes and their rise and run is different, they have to run into each other, even if it goes off the graph. Okay? It has to intersect at some point. If it's going to intersect, it can only intersect at one point. Okay? So that means it's exactly 1. If the lines are the same, it's many. Why is it many?
It's going along the same line.
It's sharing every single ordered pair. So yes. Now remember, the descriptions are just describing it, right? These have different slopes. These lines, same slope, same y-intercept. Different y-intercept, same slope. Okay? This is the only one that's inconsistent. Lines that are same and lines that cross each other are consistent. Okay? Dependent versus independent. That's fairly easy too, right? If a line is exactly the same line, it's dependent on that other line to be dependent. Okay? Versus two lines intersecting, they're going to be independent of each other. Okay?
We'll do 2.
Yes. You guys want to do 2?
Yeah.
Okay.
So the bottom one's really easy, it's just the top one because it goes along with it.
Okay, how do you want to start this problem?
Subtract 9x from both sides.
You want to work on this one first?
Yeah, that's the one. I got it done, I just want to make sure I get it right.
Okay, so how are we going to start this one?
Subtract 9x on both sides.
Subtract?
Add 9x.
Thank you. I have a question.
Yeah.
How do we write this?
9y minus 18.
Okay, and can we combine those? Can we combine those?
No.
Why not? No, not
Yes, you
not
should
One
throw
has
it in your
variable,
classroom.
one doesn't.
What's that?
She's gonna throw up in your classroom. Take that with you, man. Get out of here.
Cameron, are you doing this one?
So,
9y
No, X.
minus 18?
yeah.
Okay, what are you going to do now?
Divide the whole entire thing by -3.
Good. All this by -3?
See,
What-
the thing that I was talking about, do you leave the -9 over 3x?
We can reduce that, can't we?
That's what I was saying.
Yes.
I left it.
And 9 goes into 3 how many times? Yep, so this is y equals -3x. You do want to reduce it where there's no run, because that run is 1, where if you went over the run multiple times, it'd be an issue. Okay? What happens here?
It's 6.
Right, right. Okay, that one's fairly easy too, right?
-3x. No, we're doing the other one.
What happened?
The thing.
It's the same. Are the slopes the same?
Yeah.
Yep. Are the B's the same?
Yeah.
Okay, so you know your classifications, right? Okay.
Don't be the one.
Don't be the one. I think you guys are ready.
See,
No.
What I did is I left it -9/3, and since it was a negative fraction, it went left.
It's, yeah, and that's your issue there. That's what would cause you that issue. But Cameron, remember, if these are reversed, let's say this was 3/9, you could still reduce that, right?
Yeah.
What could you reduce it down to?
1/3.
1/3. Very good. And that would be, in slope form, does need to be reduced if it's a fraction. You don't want like 2/4 or something like that. Okay, is there anything else I need to go over?
Oh,
We're ready for this one?
maybe.
Get it. Did everyone's planner get stamped?
Yeah.
Yes.